Now, energy transfer between system and surroundings happen as heat or work or a combination of both of them, right? Delta E. In the previous video, we talked about quantifying heat. Now, chemical reactions can do several types of work, but we'll talk about pressure volume work for this class. Pressure volume work. Say, for example, we're considering this reaction. Calcium carbonate, solid, decomposes to calcium oxide, solid, plus oxygen gas. Now let's say, to begin with, we have a cylinder in which we placed calcium carbonate, solid, right? And then there is a piston. There is a piston that can move up and down. It can move up and down. So this calcium carbonate, when it decomposes, calcium oxide is formed and oxygen is formed. Oxygen is a gas, remember? So what will it do? It will try to occupy as much volume as it can, because it's a gas and the molecules are moving all over the place. So as a result, what happens? The piston, which was here originally, maybe moves up a little bit, and so now the piston's here. So there was this much of a change of volume, right? And the work done by this system on the surrounding, in this case, is calculated as negative P external, which is the external pressure, multiplied by change in volume. Change in volume. This is because this is expansion. There is a change in volume, and this work is being done on the surrounding. Work in this case is being done on the surrounding by the system, and so it is negative. Okay, W is negative, and this is how we quantify work. Now, what kind of questions will you see here? If you inflate a balloon, from 0.1 liters to 1.85 liters, and this is done against an external pressure of 1 atmosphere. External pressure of 1 atmosphere. Okay, how much work is done? In other words, how do you quantify how much work is done, right? So V1 is 0.1 liter, V2 1.85 liter, P external pressure 1 atmosphere. So then W is negative P external multiplied by delta V, which is 1 -1 times 1.85 minus 0.1 liters. This is equal to negative 1.75 liters atmospheres. That's the unit of work here, liters atmospheres. But usually work has the unit of joules. So if you were to give the answer in joules, you could use this conversion factor, negative 1.75 liters atmospheres multiplied by 1 liter atmosphere is equal to 101.3 joules. You don't have to memorize this, okay? So then your answer will be in joules, which would be negative 177 joules. And this is the kind of quantitative problems that you will get on quantifying work.